Good morning, everybody. It's a pleasure being here. And I am, as you can tell, I'm a civil engineer, so I understand about HVAC, but that's about it. So I'm going to follow on from what Tom started talking about, brilliantly putting context that buildings do not exist in isolation, and understanding the bigger picture is hugely important. So I'll stick with that bigger picture, and I'll try and describe some different thinking, let's say, that we engineers should be doing. So cities is my focus, but again, even cities are systems that are part of a bigger system, ultimately the planet. So the first, right, where do I point? Okay, perfect. So, and I will challenge a little bit. So Tom also mentioned very clearly what we perceive, what we call sustainability, particularly in the engineering circle these days, which is minimizing the impact we have on the environment through the built environment. And I'm saying at the moment, the scientists, the earth science says, we cannot afford to continue like that. There is a time we need to redefine sustainability. So sustainability is a word I mentioned very carefully. I prefer to talk about thinking of our future and crises we are in at global level. So we traditionally, as engineers, have been brilliant at building stuff, but it has happened over several years at the expense of an environmental degradation. So my slides, hopefully on time, will be about describing the problem, talking about the concept of the safe operating space from an earth scientist point of view, so I'm sticking to a global scale, and planet scale, and then some suggestions, as Tom did, of how should we, as the engineering fraternity at large, should go about it, and where and how quickly we need to do that. So starting with the crisis. Apart from political crisis from where I sit in London at the moment, there is even bigger momentum at the moment. The public is becoming really, really aware and very concerned about the climate crisis, the biodiversity crisis. All this stuff is affecting, of course, what we're doing, how we're responding about this. So engineers for centuries have been building cities to invite more people, to make them more comfortable, make sure that they can consume as they please, they can move around as they please, and so on. This has always happened sort of against the nature, so the land use changed to accommodate more and more of more people and more consuming behaviors, paving over our land, surface soil that is vital part of the natural cycle, even putting our rivers and water courses within our sewage and so on. So that is not sustainable. And that has a knock-on effect at planet scale. And it's not a local issue. It is not a building or a city on its own. It is everybody on this planet. And we only have one planet. And it has what the earth scientists call reaching the global tipping point from the environmental point. So the burning of fossil fuels, carbon dioxide emissions are changing our climate. We are losing biodiversity at an astonishing rate with the way of we're using the land and the way we're consuming things. Our freshwater systems are being at a crisis point, both from the pollution.
Sorry, of the movement.
Probably. I'm trying not to delay, but we'll get there. So ocean acidification is now a very big issue and is becoming bigger by the moment. Air pollution at global scale, at local scale, but also affecting even the climate in itself. The ozone depletion, which we know about for some time now, and of course all the novel entities, pollution of any sort, plastic being very popular at the moment. So what I described as global tipping points, the Earth scientists have come up with the planetary boundaries framework to describe that, which says planet is at very close to tipping point, not just on one thing. We are focusing a lot on climate change, and this is urgent, but there are essentially 9 boundaries that can cause irreversible damage to the whole planet at any point. And there are climate change, as I described them before, climate change, biodiversity, fresh water, biogeochemical flows, nitrogen and phosphorus, as we saw, ocean acidification, aerosol loading, ozone depletion, and pollution. So the term safe operating space is an earth science concept. So it's something that is has a scientific backing to say, if we stay within that circle in the middle, where everything is green, all 9 segments are staying green, we're okay, we can do that. The problem is already biosphere, biodiversity is shot, climate is following very soon, nitrogen and phosphorus are beyond well beyond where they should be, and some of the other stuff we haven't even managed to quantify. What I find extremely important in this global story about the planet is how all these things are, and this is a graph that another academic tried to demonstrate, the interrelationships, the interdependence that Tom already mentioned. You can't look one problem at a time in isolation from everything else. So biodiversity loss is causing even more climate change. Climate change is causing even more stress on the freshwater systems and so on and so forth. So that interdependency sounds, for an engineering solution, sounds really difficult to put our heads around, but it is vital for us to be able to design something that works without unintended consequences on one of the other segments. So, trying to summarize in a more engineering-like flowchart, we're burning fossil fuels, and we have done that since the beginning of Industrial Revolution. So we're messing up our air quality, we are producing carbon dioxide, greenhouse gas emissions, and we are depleting our natural resources at a fast rate. That has an impact to health. Carbon emissions has an impact on the climate, and all 3 of them have an impact to the environment. How our designs are going to sit around here and try and address all, remove, regenerate, mitigate, and adapt for responding responsibly and making sure that we keep the whole system working in the future. And that's how we should move towards thinking about sustainability, not just minimizing our impact. So we have a massive regenerative thing to do, and we all have a role to play in this. So health and well-being is hugely important, and you will hear a lot more about it, and it is vital to understand what exactly we mean about it when designing buildings, designing systems within buildings, and so on. But I would add to that, it is human and natural health and well-being. The 2 are also absolutely integral. They cannot have a human health and well-being with a degrading natural environment. Can we bring green and blue infrastructure back in our cities in a way that the wider system, the nature beyond it, is also benefiting, is making our cities, our buildings more resilient in a natural, effective way? So Tom already mentioned the city's resilience and 100 resilient cities. The City Resilience Index is a part of that similar sort of thinking. Stop talking about individual buildings and resilience of them. Think about a city plonked in the middle of a great catchment, for one of the better words, where the nature and the built environment are working in unison to make sure they're resilient. Very quickly, it's not a complicated matrix, just saying every single function in our cities, from the food we eat, the stuff we buy and use, the buildings, the transport systems, and so on, have at least one, if not more, impacts on all the 9 boundaries I described in that planetary boundary framework. So, and that the boundaries also have an impact on the way these functions of the urban system perform. So trying to scale down from this planetary vastness into how do we think about even a building or a road or a sewage system in engineering terms, we need to set some probably new overarching principles. These are my first take on them. I'm sure we can refine them and come up with better answers. So land use change is absolutely fundamental to what we do. We have been used to just urban sprawling because we can, particularly in the Western world. We can't afford to do that. Nature needs space to exist and thrive and regenerate itself. So what can we, with our projects, do about it? Think about, I'm a civil engineer, I often talk around, what happens at hydrological catchment levels and so on. We cannot ignore that a city that sits within an unhealthy catchment is a non-resilient city. So how does the city look after this wider area beyond its red lines or its political authorities? And talking about circularity is the best way I can describe it. How do we look after, how do we make sure that we're protecting resource use in a circular economy manner, but taking that circularity beyond that, circularity of our natural systems? How do we make sure that we do not just continue degrading our natural systems? I'm not sure my examples are the best I could do. I think Tom did a much better job, but trying to pick some big headings that this group of engineers could be thinking about when going about designs or commissioning and so on. So item number 1, we do need to reduce, to take carbon away from the atmosphere, not just reduce our current emissions. Efficiency is not going to get us there quickly. We need to do active decarbonization, change the systems we're currently using. This is a massive task. I spent the last 10 years of my life trying to see what on earth can we be doing it, and we're not imaginative enough or daring enough to change status quo, but this is urgent. So I won't go through the list. I think that has already been discussed a lot better in the previous presentation. Make space for nature. Even the economists are coming to this place big time, whether they call it natural capital or ecosystem services and so on. There is untold value at the moment in the services nature is providing for us, and without which we cannot simply exist. So the City of Manchester has a major movement that is called City Relief, and tried to quantify what the wider economic benefit is for every greening piece of work is done within the city environment, which is pretty difficult if you think Manchester is a pretty densely built city, so finding space for green and blue infrastructure is interesting. But the numbers are pretty impressive. You know, 228 UK pounds per every pound spent on this project is quite a great, you know, return on investment, if you call it in commercial terms. Can we apply more of that thinking more widely in the stuff we're doing? This is a favorite of mine. I know I live in cuckoo land, but you know, I showed you culvertization of, you know, London is proud of all the lost rivers that are buried in Victorian times under the surface. You know, the natural water system is now part of the sewage systems, for want of a better words, in London. That was the case also in the bottom slide is from Seoul, really flagship project. Cheonggi, I think is the way you pronounce it. The river was deculvertized about 10 years ago, and it brought clean air, it brought social regeneration as well as commercial regeneration, and there is absolutely no need for, there used to be a spaghetti junction in this position of double motorways in the center of Seoul. So the example on top is from, I think it's the Kifissos River in Athens, which sits nicely under a motorway, well concreted over and around it. And I can't emphasize enough the partnerships point that was mentioned. It's not coordination is the starting point, and we heard that in the previous session, but partnerships. We can't do this alone. I am a civil engineer. I understand very little about ecology, biodiversity, or even electrical and HVAC systems. So I need to have a community of engineers, specialists, experts in their topic, talking the same language. How do we get out of this mess quickly and efficiently? So partnerships for looking beyond the building envelope as well as within the building. New business models, how do you really value the stuff that we took for granted for so many centuries? What are the new skills we need to develop as the engineering fraternity and beyond? And how do we make ourselves relevant for 21st century challenges? Because there's no planet B, there have been, you know, my 16-year-old children are out on the streets saying, you're doing untold damage to us and we're not taking action quick enough. And this is becoming a global thing. We cannot ignore it and we cannot continue business as usual. And the United Nations have come up with the 2030 agenda. We have 10 years to make some vast changes to the stuff we're doing at the moment. I don't know how I've done for time, but I'm very happy to take questions after lunch. Thank you.